Hello and welcome to my presentation. My name is Anas Nassur and this is my presentation on how computers work. Okay, what is Windows 10? Windows 10 is a software. Windows 10 is the most important software that runs on your computer. This is also called the operating system. The software manages computer, memory and processes as well as the user interface. The Microsoft built software also allows you to communicate with the computer without speaking the computer language, C++ or binary. It is compatible with many different third-party applications and widely used because of its ease of use and pretty GUI. Here's a link where you can access it. The main functionality of Windows 10 is to manage input and output devices with a modular approach towards the hardware and software. Let's see. Okay, so now we have the hardware, software, peripherals, and utilities. So as you can see, we have all of these components, and what Windows 10 does is combines all of these pieces of the puzzle and makes the computer work. We can see all of this happen with the aspect of modularity. The software, the hardware, peripherals, and utilities. To help us further understand the aspects of the operating system, we can look at these two pictures as a representation of the concepts of the operating system. Here we have a picture in a nature, and we can abstract it via calling it the kernel. This is a spider, and we can see every single ring can be attached to a driver right here, where we can connect all of the aspects of the modularity towards it using the drivers, as I said. So, yep, and deeper we go, the more secure it is. We can also abstract it using a puppeteer, and we can call Windows 10 as a puppeteer, and who controls all of these aspects. So, the different aspects that I'll be explaining of Windows 10 will be the user mode, kernel mode, and the hardware. The user mode is a collection of windows with a graphical user interfaces with a plug and play facility run by the user mode drivers and Windows API. The kernel is a backend of the computer and manages the peripherals, the properties of the files, and executed by the memory, CPU, and back into the user mode in a push-pull configuration, also known as fetch and execute. Hardware. We can think of the hardware as an intermediary between the software and the different physical components that are controlled by the operating system, e.g. hardware and CPU. In this demonstrations, we'll be calling the hard drive the SSD. So this is an abstraction of Windows 10. The abstraction diagram shows an operating system and how it communicates with the user mode and the kernel mode. This is the user mode, this is the kernel mode. We have abstraction layers towards the hardware, as I have explained previously, and we have the user mode with the APIs and the user mode drivers and how they interact with the user, and on this side, this is how the kernel mode interacts with the hardware. So it's basically how I talked about the puppeteer. Okay, so we have peripheral devices over here. This is a device manager with all the drivers for universal drivers. The universal drivers are made by Windows 10 so that all third-party manufacturers can make their products so that they are universally compatible with the device with Windows 10 operating system. So if for example your device has more complicated functionality, then you would have to install the drivers into the device manager from your third-party provider. Right here we have a graphical tablet. So let's see how this all works. We have installed the third-party drivers into the device manager, and it is then run. This is an off state of a laptop or computer, and this is where the computer is not running, and this is a state where none of the components are working or being used. So once we turn on the computer, we go into an on state where the computer is loading all the files into memory, into the registers, and allocating all the registers a certain amount. All the files are being processed, and then we go into a sign-in state, which is a user input state. In this state, we can see that we have a PIN or a password where we can enter that, and the user is expected to put an input. Here we have a user GUI state input, but this is an any state because the user controls what state he or she can go into. So we can see this is a fixed state, any order state. Let's talk about that later. Abstraction of the notional machine. We can see we have the RAM, motherboard, SSD, and the network card. Also, we can abstract this as a system bus. So we can see this application here is being allocated some memory registers and being converted by the drivers of Windows 10 to machine code, and which consist of jump, load, and add, and then is processed by the program counter and placed in the instruction register, and then is calculated by the ALU, also called the arithmetic logical unit. Let's say that it adds register 1, register 2, and applies it to register 3, and then puts it back into the RAM. Okay, so Windows 10 has the basic security of Windows 10. The basic level of security within Windows 10 is a password to access the operating system. When the user picks a password, it is then assigned random values based on the random algorithm. In computer science, we call this hash text. One of the most popular hashing algorithms used in Windows 10 is SHA-2, a 256-bit key hash. As you can see, this is a linear approach, and it is only one way where the hash is placed. So it can go only one way. The text is then encrypted and stored on the SSD for later. Basic security of Windows 10 Part 2. In this stage, the user types in a password and sends it off to the Windows to verify if the password is right. Only when the user types the right password and it matches the random algorithm of letters, numbers, or characters can Windows 10 allow the user to access the main operating system. There's also an extra layer of security, and it restricts the user from typing the password for more than a set amount of times. Right here. So let's type in our password and see what happens. Oops. Okay. So now the hash is given to the operating system, and if it matches, we get access granted. Let's go into the operating system itself. This is the graphical user interface of the operating system itself. So let's describe it. So it has a beautiful GUI. It has a start button or a search bar right here. It has a project area or a desktop, as you would call it. And we have a taskbar with applications on demand. We have shortcuts on the desktop. And now let's run into the operating system itself. Okay, so let's see what happens when we click on the Windows icon right here. As you can see, it pops up and we can have access to every single application that is installed in the operating system itself. When we type into the search bar right here, it has a predictive typing algorithm. This is based on a pre-trained machine learning algorithm. It helps us to predict what text we are going to type in next. If we click off and we go to Google Chrome right here, Google Chrome, if we hover over the application itself, we can see a preview of the application itself. And if we hover off, the application goes off the preview. And now let's click on an application in the desktop area. Ooh, okay, cool. So we have clicked on Microsoft Outlook right here. So we will focus on the aspects of the window. We can see right here we have the minimize, maximize, and the close button. If we get the maximize button, we will see that we can go into the system program and we can put it onto full screen so that we can see all the aspects of the window itself and the application itself. So let's now minimize the window. It is still stored in the RAM right now, but it is accessed on demand from the taskbar right here. We can access it if we click onto it. So yeah, we can see it. So now let's remove this application from the RAM, and we can do that by closing the window. Okay, cool. So let's see how we can relate this to the aspect of paging. So we can see at the bottom we have an abstraction of paging. Every single program is stored on the SSD, then is allocated some space on the RAM. Before a program goes from the SSD, it is passed through the security like the Windows Defender or the firewall. And it is also allocated a certain amount of RAM right here for RAM registers. See Google Chrome, Adobe Illustrator, Photoshop, and we can see Microsoft Outlook. Every piece of is allocated a piece of memory from the register, and there's a smart algorithm that if a program wants to use more memory, then it is allocated more registers, but no program can access another program's registers. We can see these aspects from the Task Manager, which is a utility within Windows 10. Right here we can see that this is the memory or RAM. Every single program is allocated a certain amount of RAM or memory in here, right here. So 259 megabytes, and we can see right here on my computer I have 40 gigabytes of RAM, and we have 26 gigabytes available and some virtual RAM right here that is extra. Thank you very much. My name is Anas. If any questions, please email me.